In this video we're going to work through the introduction to complex numbers, and we're going to start by talking about definition of a complex number. Complex numbers come about because we need some way to deal with the root of negative numbers. So we begin by saying the square root of a -1 is the symbol j or I. And I'll try to stick to j. If I do use I sometimes, that's the same symbol. We try to use j here because I would be current from electrical applications, which is a common place we do use complex numbers. So we'll try to stick with j. So j is equal to the square root of -1. And if you square it, then j squared would be -1. And that'll become important very shortly. In essence, if we have the square root of -a right here, then that's the same as j times the square root of a, because we take the -1 root, which is the symbol we're looking for, and replace it with j. And this is true for any a bigger than 0, which makes sense. If a was less than 0, -a would be positive anyway. So let's try to simplify these, and I'll do them in 2 steps. First we'll say, well, the root of -9 normally we can't do until we get this symbol j. So we're going to start by saying, well, the -1 is the problem. So we'll take that, and we'll say that's the same as this. Another way to say that then, well, we know the square root of 9 is simply 3, and the square root of -1, well, that's this new symbol we're going to talk about, j. And so that's how we go about simplifying this. Similarly here, we have the negative root becomes named j, and we're left with the 5 under the root, so we write it like that. Typically the j, or any letter really, would come in front of the square root sign so it doesn't get lost back at the end here. Very important that you take extra care when you're working with the square root of negatives, and we try to simplify the negative roots first. And so in this instance, what we would do is we'd actually say we're going to leave that squared. The square root of the negative, well, that's going to give us our j. And the 4 then is going to be, the root of 4 is 2. So really what we're dealing with is 2j squared. And then that's going to be 4j squared when we square both parts. And now that becomes -4. And the last one here then, the negative under the root gives us j. 45, well, that's 9 and 5. So that gives us a whole number 3 from the 9. And root 5 left under. So we simplify the radical just like we would have when we learnt radicals with positive numbers. The powers of j, well, they can change just like any power can. So we can be power 1, power 2, and up. And you notice we get this nice little pattern here. Power of j is just j, or power of 1 is just j. J squared, -1. J cubed is -j. See here we have j squared, which is -1, so that gave us this. And j left over. J squared and j squared, well, j squared is -1, -1, -1, +1. And notice here, when we get to 5, it starts to repeat, because now we have 4, which is 1, and 1j left over, which is j. And you'll see this pattern, it just repeats. Using this pattern, then, we can talk about reducing the powers of j. If the power is even, we follow this formula, which we'll demonstrate in a second. If the power is odd, we follow this idea. So here we have j to the 51. That's an odd power. So looking at this little rule here, it says we're going to keep 1j. We're going to, in brackets, put j squared. And this will become important in a second why we would do that. Now, if we keep 1j, that gives us 50. We had 51, this 1, that gives us 50 that we need to deal with. Well, 50 is 25 times 2. So using our exponent rules, this is a different way to write 51. We take 1 here, 2 here, and then we take the number, in our case 51 minus 1 is 50, divided by 2 is 25. So that's the rule we just applied, the odd power. Now why is that useful? j squared is -1. -1 to the power of 25, well, that's simply -1. So the answer here is simply j. So we're always going to be able to reduce the power to the first power of j, or j to the power of 1. Sometimes it'll be negative, sometimes j will disappear altogether, but we can always reduce it. So here j to the power of 26, this is even. So if it's even, we keep j squared. Divide that by 2 is 13. So that's negative 1 to the 13, or simply negative 1. And we can continue doing that for these two here. Doesn't matter if there's more, we're just using order of operations here. J to the 9, we're going to keep a j. And that leaves us 8, which is 2 times 4. 12. 11 is odd, so we keep 1. Leaves us 10, which is 2 times 5. Minus 7. 18 is 9 times 2, so that's simply 2 and 9. And if we simplify, this is 3j. This is negative 1 to the 4. That's positive, so 3j. Negative 1 to the 5 is negative, so this is minus 12 now. So we'll change that plus. This is now minus 12j. Negative 1 to the 9 is negative 1 times negative 1 is plus 7. So that's negative 9j plus 7. Last example, quickly do here. Hopefully you can follow along. Negative 2, this is going to be j squared and 50 plus 5. This is going to be j and j squared and 63. And this one we can actually just say this is 16j squared and 13. Change the order of the exponents there. And simplifying, this is going to be negative 2 minus 5j plus 16, or 14 minus 5j. And so that's how we're going to use j, or the root of negative 1, to represent those complex numbers.